This video is for Chemistry in the Earth System, Unit 3.4, Lewis Structures and Molecular Geometry. Today's essential question: how do Lewis structures and VSEPR theory explain the unique properties of water? Our first main idea: the molecular structure of water. The molecular geometry of a compound can help explain the properties of that compound. We think of water as a very common substance, but its molecular structure makes it unique in some ways. The polarity of the water molecule causes strong hydrogen bonds in all directions. Under the surface of a sample of water, the attractive forces act in all directions. On the surface, however, the forces act downward and then to the sides toward the other water molecules. This creates surface tension, which minimizes the surface area and causes a tight layer of molecules on the surface of the water. It also causes water droplets to form rounded beads. In addition to creating surface tension, the hydrogen bonding in water also helps to explain the unusually low vapor pressure in water. As was explained earlier in this section, hydrogen bonding is the strongest of the intermolecular forces. This strong force helps to hold water molecules together tightly. This has a large impact on how water behaves on the surface of Earth. Since the vapor pressure of water is low, it does not readily evaporate from the surface of Earth, which is insanely important for life. Another unique property of water is that the density of ice is less than that of liquid water at the freezing point. Therefore, unlike almost all other materials, water bodies such as lakes and streams freeze from the top down. This is an advantage for life in marine and freshwater ecosystems where water remains in the liquid form at the bottom of a lake or ocean, even when it freezes at the surface. This is also why ice floats in water. If ice is placed in a glass and then the glass is completely filled with water, the ice will float above the lip of the glass. If the glass of ice water were to be left untouched and the ice were allowed to melt, the water in the glass would not overflow. In ice, water molecules are connected by hydrogen bonds and arranged in an open hexagonal grid. This leaves a lot of open space, and it is not the most efficient way to pack molecules. So when water melts, the structure is partially broken down, and the molecules move closer together. Even though molecular mobility increases, density increases. At this point, you should be able to generate a full and appropriate response to today's essential question: how do Lewis structures and VSEPR theory explain the unique properties of water?